Let's talk about solving quadratics by taking square roots. Now, a couple things to remember. Quadratics are polynomials that have a degree of 2, which means that they're going to have two solutions. So if you solve an equation like this, which is typically your final step in the Pythagorean theorem, you take the square root of both sides of that equation and you get x equals 5 if you're doing the Pythagorean theorem. But if you think about it, positive 5 works in this equation, but so does negative 5. If you substitute positive 5 into the original equation and square it, you get 25. And if you square negative 5, you get 25 as well. So because we have a degree of 2 in this quadratic equation, we're going to have two solutions. So when you take the square root of both sides of an equation, make sure you include a plus or minus. The reason we don't do that in Pythagorean theorem is because Pythagorean theorem is dealing with the lengths of the sides in a right triangle. And we know that length must be positive. So we only use the positive version. But for these, we have two solutions, so make sure you do the plus or minus. Now, quadratic equations have a standard form of ax squared plus bx plus c equals 0. And there are lots of different ways to solve these. You may remember the quadratic formula, have a nice song for that. And completing the square is another way that you can always solve quadratics, no matter what they look like, no matter what values they have, or what types of solutions they have. You'll be able to find them using both of those ways. But then there are other methods that only work sometimes. Graphing is one that only works when you have real solutions. Because remember, when we graph polynomials, the solutions are where the function's graph crosses the x-axis. So if we have imaginary solutions, then the function is not going to cross the x-axis and we won't be able to find those. So real solutions only for graphing. For factoring, the methods that we use generally only involve rational solutions. So if you have square roots or any non-repeating, non-terminating decimals that are solutions for your problems, then you're not going to be able to find those with factoring, generally speaking. Square roots is the method we're discussing right now. And square roots can only be used to solve quadratic equations if the value of b is 0. Because if the value of b is 0, then we'll be able to essentially get rid of that b term. Because 0 times x is just 0, and we all know that 0 plus anything else gives us what we had to begin with. So square roots can only be used when the quadratic equation looks like this. So the examples you see in this video will all be missing a b value. So no linear term, just the quadratic with the x squared and the constant with no x at all. So if you look at these four examples, which ones can you use square roots for? In this first one, we've already got 0 on one side, which is our first step for solving quadratic equations. And if you notice, a is 3, b is 5, and c is negative 2. Remember, to solve using square roots, b has to equal 0. So we cannot use square roots on this problem. In this second example, we have a equals 2, b is 0 because you don't see a linear term, and c is 5. And because b is 0, we can use square roots to solve this equation. For the next one, it's not in standard form yet, so we don't have a 0 on one side. To get that 0 on one side, we're going to move 2x squared to the other side. We generally like for our quadratic terms to be positive. It doesn't ruin it if they're not, but that is helpful usually. So we have 2x squared plus 2x equals 0. And now you can see that a is 2, b is 2, and c is 0. Well, something is 0 here, but we're looking for b to be 0. And in this case, that's not happening. So we cannot use square roots on this one. Finally, to get this fourth problem into standard form, we're going to add 5 to both sides. And that's going to give us x squared plus 5 equals 0. In this one, a is 1, b is 0, and c is 5. So, since b is equal to 0, we are permitted to use square roots to solve this problem. Let's try solving a few of these. In this first one, notice that when I write it in standard form, I have x squared minus 16 equals 0. And because that's the case, and a equals 1, b equals 0, and c equals negative 16, I can solve this using square roots. So the first step to solving using square roots is isolating the x squared. And that was already done in this problem before we started it. So we're going to continue with it in its original form. And to undo squaring, we use its inverse operation, which is taking the square root. We're asking ourselves, what can I multiply times itself to get x squared? Well, the answer to that question is x. And what can I multiply times itself to get 16? There are two answers to that question. One of them is positive 4, which is what we generally think of, but the other one is negative 4. So don't forget to include the plus and the minus version in your answer so that you will have a number of solutions equal to the degree of the problem. In our next problem, we need to isolate the squared term first. So I'm going to divide both sides by 3. And when I do that, I get y squared equals negative 16. Next, I take the square root of both sides. And when I take the square root of y squared, I get y. When I take the square root of 16, remember, when we take the square root of anything that's negative, I will be part of our answer. We can rewrite the square root of 16 as the square root of negative 1 times the square root of 16. And the square root of negative 1 is I. The square root of 16 is 4. So I get 4i. But we still need to remember to do our plus and minus on this solution. So the number of solutions matches the degree. In this problem, it's in standard form right now. Again, you can see that b is equal to 0. There's no linear term. But I need to isolate the x squared. To do that, I'm going to subtract 24 to undo the addition. 24 minus 24 is 0. So I have 12x squared on the left is equal to negative 24 on the right. Next, I need to divide to undo the multiplication. And 12 divided by 12 is 1. So I have x squared on the left, and negative 24 divided by 12 is negative 2. Now once again, I'm going to take the square root of both sides, and the square root of negative 2 is equal to the square root of negative 1 times the square root of 2. The square root of negative 1, once again, is I, and the square root of 2 is not a perfect square there, so we're just going to leave it as a square root. But we're also going to remember to put the plus or minus so that the number of solutions matches the degree of the function. Next, here you'll notice that we do not have a 0 on the right-hand side of this equation, but that's okay. We're going to solve this using square roots, and that means that I need to isolate the squared term first. So once again, I'm going to subtract 79 from both sides, which will give me negative 72 on the right, and on the left, 79 minus 79 is 0, and that gives me 3a squared equals negative 72. Next, we divide both sides by 3, and 3 divided by 3 is 1, so we have a squared equals negative 72 divided by 3 is negative 24. So now I can take the square root of both sides since my squared term is isolated here, and I'm going to get a equals, remember this is the square root of negative 1 times the square root of 24. Or I could write the square root of 24 as the square root of 6 times the square root of 4. Because all of these radicands multiply together to give you negative 24. The reason I broke it up like that is because I know that 4 is a perfect square, and I know the square root of 4 is 2. I know that the square root of negative 1 is I, but 6 does not have any perfect square factors, so I can't break that down any more than it is already. So my final answer is going to be plus or minus to give me the two solutions, 2 for the square root of 4, I for the square root of negative 1, and the square root of 6, since that can't be simplified. And those are all the practice problems for this. Feel free to try some more on your homework pages or ask questions if you're still not quite sure how to do these. Thanks.